Hello students, welcome to your Destiny JEET, and I am your mentor Ratnesh sir. Today we are going to discuss a question of physics in the chapter Refraction of Light. Actually, in the social media domain, a question is rotating, you can say, it is revolving or rotating, whatever you can say, and it is creating too much confusion in the mind of the students. Basically, what should be the right answer to the question, and that question I am going to discuss here. To discuss that question, I want to relate that question to another question which I will also be discussing to get the clarification of the explanation. Okay, the first question you can see on the board what it states. Let us read: lateral displacement dash with increase in angle of incidence. Options are: A increases, B decreases, C remains same, D keep changing. Now what is the answer for this? Answer is increases. Why? Because we have some parameters for which affect the lateral displacement, and one of the parameter is your angle of incidence. Actually there are three parameters or three things which affect the lateral displacement length. Now what are those three things? Let us see on the board. There you can see on the kiosk that first is your thickness of the block, you can say, or medium, and what it is: more the thickness, more the lateral displacement. Second condition, again you see on the board, it is the angle of incidence. What it says: more the angle of incidence, more the lateral displacement. And third condition which affects lateral displacement is the refractive index of the block, you can say, or you can take in other ways the wavelength of the light. Here also, more the refractive index, more is the lateral displacement. Now one thing you should learn it, or you take it as a trick, or just to remember, you can take that as a trick. What it is? It is that, see, whenever we are studying the conditions for the change in lateral displacement, all the conditions point out to a single thing, that is more. Means more of the thing, more is the lateral displacement. There is nothing to be confused about. All the three conditions say that if they are more, the lateral displacement will be more. This is more important, keep it in mind. This will help you to understand the question more better. Now let us see some diagrams here. You can see two diagrams first of all, and you can see the red rectangular figure which is actually denoting the glass block. Actually it is a glass block. Okay, this glass block refracts the ray of light which is incident on the surface of the block, and it gets refracted, and after that the emergent ray comes out which passes like this. Now this refraction causes the deviation of the light from its original path by a distance of x. Okay, now this x, here you see, and here you see, we take the angle of incidence 60 degrees now and refractive, then what we get? We get the displacement more bigger. Here the displacement is more, here the displacement is less, here the angle of incidence is less, here angle of incidence is more. The more the angle of incidence, more the lateral displacement. From that, what we understand. Now how did I get it? Let us see. So first of all, we should know the second law of refraction also. Here we have sine 45 degrees upon sine 28 degrees and 0.701. Actually you may be thinking how I got this value. So you can take it from what? The natural sine table which you may have at the back of your maths book. Okay, and likewise we can get the value of 28 degrees also, which is 0.4693, and approximately it will give you the answer 1.5. Now if you take the other one here, sine 60 upon sine 35, sine for 35, what do you get? 0.8660 upon 0.5736 is equal to 1.5 again, approximately. So we are getting the refractive index of glass as 1.5, and we see that the increase in the angle of incidence increases the lateral displacement. Now comes the real point of discussion. Angle of incidence increases, lateral displacement increases. With the increase in angle of incidence, angle of refraction also increases. Here angle of incidence was 45, angle of refraction was 28, angle of incidence 60, angle of refraction 35. From this, what do we get the conclusion? We get the conclusion that with the increase in the angle of refraction, the lateral displacement increases. Okay, now we come to the real problem which we are facing. A question is there in the public domain or in the objective books. You may have come across that. The question is what I am reading it out, and you can see on the board. Greater the angle of refraction dash the lateral displacement. Options are A, same, B, more, C, less, and D, can't say. And the right answer given in the book is less. Now you may get confused. See, just now I told you that here the angle of refraction is 28, here it is 35. It has increased, means angle of refraction has increased, and the angle of the lateral displacement also has increased. How is it so that the question's answer is also right and my explanation is also right? For this I'll have to go to another slot of discussion, then we'll come to the conclusion which is right or wrong. Okay. Now we can see two more slabs. This time I have taken two slabs of ice. Now you may know that, or if you don't know, you see the table of refractive index. The refractive index of ice is 1.31, whereas water is 1.33. Now you may ask, why did not you take water? Because we generally compare glass and water in our chapters or in our lessons. I did not take water because water would be in a container made of glass maybe, and then the argument may come from your side that there is glass in combination with water, therefore what should be for explanation for that. I do not want to go into that argument, therefore to stay away from the argument I have taken the block as ice. Okay, and refractive index of ice is 1.31. Now let us see what angle of incidence here is. 45 is the angle of incidence here, and we have an angle of refraction here 33 degrees, because we know that sine 45 degrees upon sine 33 degrees is equal to 0.7071. These values I am taking from the natural sine table which is at the back of your math book. You can check it out from there. Okay, don't get confused from where I am writing the values in decimal. That is not a very serious matter. Now instead of 3.1 I have written approximately 1.3. Let us see this one. We have angle of incidence here, how much? 60. Angle of refraction will be 42 here, 42 here, and 60 for the emergent ray. Now here we get sine 60 upon sine 42 degrees is equal to 0.8660 upon 0.6691 is equal to 1.3 approximately, and these are the values for what? Refractive index of ice, therefore these are true. Now you can see here that when the angle of incidence is 45, this is the lateral displacement, whereas when the angle of incidence 60 degrees, we see that the refractive index has lateral displacement has increased again. To two sets of diagrams I have shown, where I have shown you that when there is increase in the angle of incidence, the lateral displacement increases. And it is true relatively, because when the angle of incidence increases, angle of refraction also increases. From 45 we go to 60, here angle of refraction becomes from 33 to 42, and when the angle of refraction is increasing, the lateral displacement is also increasing. Now how can we say that greater the angle of refraction, less will be the lateral displacement? For this we have to understand the concept in another way now. That I'll show you in the next slot. Now you can see I am taking two different blocks, slabs. One is of glass and the other one is of ice. Refractive index, you know, of glass is 1.5 and of ice is 1.31. So we have shown you the two slots in which I have shown you the refraction through ice and as well as through glass. Now I am taking same angle of incidence for both and trying to sort out the answers. Now you see, for angle of incidence as 45 from air to glass, the angle of refraction will be 28 degrees. Whereas for ice, if the angle of incidence is 45 degrees, the angle of refraction will be 33 degrees. Since the refractive index of ice is lesser, the angle of refraction will be greater. The angle of refraction means the ray of light is not turning towards the normal too much. Here it is turning towards the normal too much. Therefore, the angle of refraction in case of glass is lesser than the angle of refraction in case of ice. Now we come to the emergent ray. We see, since the deviation was more in case of glass due to its refractive index, the lateral displacement also is more in comparison to ice's lateral displacement, because here the deviation from the original path was less. We come to the conclusion that in these two cases we see, when the angle of incidence is the same but the refractive index of the media of two different media are different, the angle of refraction will be different, and greater the angle of refraction, lesser the lateral displacement. Then we come to the conclusion that the question given in the book, that with the increase in the angle of refraction, the lateral displacement will be less, is right, but for a particular condition. Therefore, we cannot say the question is wrong. The question is incomplete. We have to understand the question in this format, which is not given clearly in the question itself, and it becomes difficult for the children to explain it. But remember, they have actually used this concept to show that the angle of refraction increases, the lateral displacement decreases. Okay, it is clear. I think you have understood and got satisfied with my explanation. If so, I'll be very much happy, and write in the comment section if you have liked it or not. And if you have any other queries, surely you can ask me before your exams. I'll try to sort them out also. Thank you.